Hi guys, today I'm going to be talking about how to build a network attached storage device or a NAS. Now, if you're unfamiliar with the idea of a NAS, it's a pretty straightforward concept. It's basically a storage server that you can attach to your network. And then with that storage server, you can store all kinds of different files. You could store videos and photos and documents, and you can access them over your local network or even over the internet. Now, another thing you can do with NAS devices is install apps on them. And these apps will take advantage of all that storage. So you can install apps that host files, or maybe it's just serving up some kind of media server that you can use to stream movies or whatever it might be. There's a lot of different applications for it as well. So not all NASs are built with the same kind of purpose in mind. So there has to be some kind of consideration for the intended use of your network attached storage device. So to help guide that decision making, I came up with a matrix that I was using to help me figure out which components I would use if I was going to build one. So I applied this matrix to my use cases, and then it helped me choose some different components that I put into my storage device, and then I built it. So I want to kind of guide you through the process, look at the matrix itself, and then talk about the different kinds of use cases for a network attached storage devices as we go through that. And then I'm going to talk about the parts list of the storage device that I build and why I chose them. And then I'll go through the build process itself, which is pretty straightforward. So let's go over to the matrix, take a look at that, and then we'll go over to the build and look at my build and all the stuff I have going on there. So let's talk about the matrix here. It's pretty straightforward. So across the top, I have uses, and we're going to be talking about 4 categories. And then within these categories, there's some use cases that we can look at. And then for the categories are bulk storage, media streaming, VMs and apps, and network shares. And then on the left here, we're going to have hardware considerations, which would be the kind of storage that you would want to use, the configuration of that storage, and then the networking to provide that storage to your network. So network attached storage is of course going to emphasize networking and storage. Now there's other hardware considerations that you might have to take into account whenever you're building a network attached storage for specific use cases. We'll get into those as we kind of walk through this. But in any case, let's just talk about bulk storage. Now, network attached storage is generally speaking designed for just this kind of bulk storage, Nextcloud or just backups. This would be that kind of idea here. And so this is more passive storage, where if I'm working on a document, for instance, and I hit save, it saves it to my local disk, but in the background, there's an app that will then in the background sync that with the storage server. Or in the case of NVR, this I'm just worried about storing surveillance data. And for this, you can really just use mechanical disks for this. Mechanical disks have the best price per capacity. And there is a specialty kind of SATA HDD, and that's a surveillance drive. And surveillance drives are generally designed for doing NVR application. Now, the storage kind of configuration that you might want to use on this is mirroring. Mirroring is basically where you have 2 disks and the data is written to both disks. So if one disk fails, you still have a copy of it. And for networking on this particular instance, you don't really need a ton of networking for this to work. 1.1 gigabit to 2.5 gigabit Ethernet should be fine. If you want to take this to the next level and use it for more than just bulk storage, this is where you can use something like media streaming. So in this case, you would have a server that is a network attached storage device, and then you install an app on that server that's designed to provide the streams from your movies, your pictures, or your music to client device. Plex provides you an interface where you can kind of shuffle through all your movies and you say, hey, I want to watch Indiana Jones tonight. Now, another thing that you can do with media streaming is transcoding. And this is where you can take data from its original form and translate it into something that is consumable by the client. Now, to do that, you need some kind of hardware to do the transcoding, and you might want to have something like a GPU or a high performance CPU to make that transcoding possible. So with that in mind, the kind of storage that you would use for this would be something like SATA HDDs or what they call SAS HDD drives. Now, SAS is a format that is typically used in server applications. It's still a mechanical disk, but it's a higher performance spec. So SATA will typically go up to 6 gigabits per second, but SAS can go up to 12 gigabits per second. So these are typically drives that are used in servers, but you can find them available. And you, with a card that you can put into a PCIe slot, you can use these in a standard desktop as well. Sometimes these drives can actually be cheaper than SATA drives, and as of the making of this video, they're pretty comparable, maybe even better price than the similar capacities that you would get from SATA. So the kind of configuration that you might want to use on this is mirroring. Again, just 2 disks minimum, and you have your primary and your secondary. And the networking requirements is typically 2.5 gigabits or better. So let's talk about VMs and apps for a second. Now, this is where you start to get into applications that run on top of your storage. Now, given the gamut of everything that you can use VMs for and apps for, it's really hard to make any specific recommendations. But typically, if you're going to be running apps that are going to be or storage oriented, that are going to be running in a VM or a Docker container or something like that, it's probably going to be an app that needs some kind of operating system. If you're going to be running a virtual machine, or if you're running something that's a Docker-based application, you're going to need something like a database or something like that. So in these cases, your storage configuration is probably going to be something that's higher performance than just your standard HDD. And this is where SSDs kind of come into play. Now, the great thing about NAS appliances typically is they give you the ability to create storage pools. So if you wanted a high performance storage, you could set that up fairly easily and have a storage pool for high performance storage. It's probably lower capacity, but it's going to give you better throughput. And then you could have just your mechanical disk in another pool that would be for that bulk storage. Now, this is also where you might want to think about striping. And striping is basically where you have 3 disks involved in your set. Now, mirroring has a 2 disks that are identical. Striping takes advantage of parallelization in writing and reading data. So in this case, when you write data to at least 2 disks, and then you have a parity bit on a 3rd disk. So it takes advantage of writing data simultaneously, so you get better throughput. And again, gigabit Ethernet is probably a little bit slow for some of these applications, but you might work. But I would say just go with 2.5 gigabit Ethernet. Now, over here on the right, I put network shares as their kind of their own category, and I wanted to consider this one separately than just standard bulk storage. Now, network shares could just be bulk storage. By network shares, I'm talking about just mounting a drive, like a Z drive on your Windows box that allows you to just write and read data like it was a part of the actual file system that was coming from a local disk. Now, for network shares in this case, I'm talking about network shares that you're using for applications that need data. So in my case, it might be something like Photoshop or Premiere, where I have data that's stored on a network attached storage device, but I'm using a local app to edit. And so to do that, I need fast storage over a fast network. For this, you can use any one of these kinds of disks, depends on the need of what you're using. Now, for photo editing and video editing, SATA disks are probably fine. If I was writing code a lot and I was going to be doing that over network share, I'd probably want to use an SSD. Now, for my use case, though, I went with 10 gigabit Ethernet because I wanted that high performance throughput. Now, 10 gigabit Ethernet can come in a lot of different media. You can use fiber. You can also use DAC, or you can just use, good old fashioned twisted pair. Now, in my case, I actually went with DAC, and this allows me to get 10 gigabit Ethernet, but with a lower latency. Now, if you're going to have a storage server that's located at the other end of your building, at the other end of your house, DAC's probably not going to work for you. You need fiber or Ethernet for that. So let's go ahead and look at the parts that you might want to put into this, and we'll look at some prices and where you can source some of these parts and some of the advantages and disadvantages of using different configurations and so on. So building this is not hard. You basically need a chassis, drives, and networking. And the chassis just to put all the drives in, and the networking, of course, to connect it to your network. The chassis doesn't have to be anything high end. In fact, I went with something that I was given. So this is a box that somebody was going to throw in the trash, and they gave it to me for free. And so it was of no cost to me, but you can get these on eBay for not a lot of money. And so this box had, I think, 16 gigs of RAM and a small solid state drive in it that I was going to use for my build. And so I am using a Dell Inspiron desktop that was made probably 9 or 10 years ago. But if you want to buy something, you can go out to eBay and just type in desktop computer, and you can search on this and then look for something that's 16 gigs of RAM. That's because you're going to want at least 16 gigs of RAM to run something like TrueNAS, which is the software that we're going to be talking about. And you can go with a tower. You could do a mini tower or something like that. I don't know that I would go with anything that was small form factor, but that would be fine. And then come down here and set a max price of like $75. And you will get a list of results that would probably work fine. So let's pop open a couple of these to see what we're dealing with here and see what we're looking at. And the prices seem to be all over the place, but they do seem accessible. So let's take a look at a couple of these. So this is a smaller machine. This is an old HP desktop that doesn't really list anything about the price. So I don't know anything about that one. No one is listing the specs either. So I'm going to kind of ignore them. I like these HP Z series though. These are great towers. They're mid towers, and they have a lot of space in them. So you can put a lot of drives in these things. So they have these 5¼ bays up here that you can use. You can use these bays right here for drives. And then you have this kind of empty space down here that you can mount stuff in as well. So you have a lot of space for mounting drives in. And they also have a fairly decent power supply that you can power all that with. And then they have a couple of PCI Express cards for expansion. So if you wanted to use like this for network, if you want to do like transcoding or something like that, this would be a great option for that and still be able to use high-speed networking because you have a lot of 8x PCI slots in this one. So I like these right here. These OptiPlex, this looks like a decent one here. It's a small machine, but I think with some effort, you could have put a couple of drives in this and it would work fine. Very similar setup right here, 5th gen i5, 7th gen i7 there. This is a 6th gen i5 OptiPlex, another smaller machine, but with some finagling, you could probably make that work as well. And this is an older Dell with an 4th gen i7 in it. And this looks like a OptiPlex machine. This is a tower here. This one will have a lot of space. This is very similar to the Z series towers. So you can see you have a lot of space down here for mounting drives. It's got 2 bays, this bay right here, and then you got these 5¼ and then it's got a couple of 8x PCI E slots on it and 16 gigs of RAM. So yeah, that's actually not a bad build right there. There's no drive in it, but you could probably pick up a small drive for the operating system. So this would be a good option here, or maybe one of these Z series like this. This one doesn't have a drive either, but that's a little bit more than I want to pay for it. But it would get you by. But in any case, you're getting a case, the RAM, the CPU, the motherboard, and basic networking for $33. So you get a lot of bang for the buck when you buy something like this, which will work fine for just bulk storage, and most of the time will work for most applications for like a home lab type setup or a NAS light if you're going to go with that option. Now, as far as the drives go, I went with 3 HGST SATA drives. So these are 8 terabyte drives, and I put them in a striped set. So I get the capacity of 2 with a parity drive. So that gives me 16 terabytes of capacity with three drives. If you're using mirror, you only get the capacity of a single drive, but you have a full mirror of the data. So if you bought 2 8 terabyte drives, you would get 8 terabytes of storage, but you would have a full mirrored copy of your data. With a drive that is in a striped set, you have a parity bit, and then you have the data written in a striped configuration. So if one fails, you have to rebuild the set, but you don't lose all your data that way. So I can still lose one drive and replace it, but still get the capacity of at least 2 drives. Now for networking, there's options here, but let's talk about the cost of drives too, because drives can be the most expensive component you're putting in this, and that can be all over the place. So if you're looking for drives, you have the option of new or used drives. So 8 terabyte HDD SATA drives can be very expensive if they're new, but they're also could be very inexpensive if you buy used drives. So these are used drives right here, these HGST Ultra Stars. These are going to be refurbished. So $70 for an 8 terabyte drive there, but you are going to pay around probably $150 or more for a brand new drive. So almost twice the price for a new drive. So my application, I ended up going with the used drives. Now, if I was going to be using this for mission critical data that I care to lose, I would use new drives. I wouldn't buy used drives, but this is going to be mostly for stuff that if I lose it, I'm not going to cry. I don't care if I lose it. It's not going to be a big deal. And so I went with used drives, and that's what I'm going to stick with. So I put 3 of these HGST Ultra Stars in there, and they work just fine. So let's talk about networking now. Networking is a small cost, but it's something that you need to consider if you're going to be doing anything that's beyond the built-in networking that comes on most machines, which is typically a 1 gigabit port. unless you're just buying bleeding edge, which would be a 2.5 gigabit port. I went with these particular cards right here. These are HP dual port 10 gigabit cards with an HSFP plus on them. Now, the reason I went with these is because they're not very expensive. I got these for, I think I paid $37 for each. So I got the pair for about $74, but these are for $46. So you can get these SFP plus cards for not a lot of money. And they come with an SFP port on them, which is this port right here. Now, SFP is a standard that allows you to use different media with it. So you can use usually one of three different kinds of media. You can use SFP plus supports Ethernet. So if you want to go with Ethernet, you can use that. You can also use fiber optic, or you can use DAC cables. I went with DAC cables because DAC cables uses a coax cable that has very low latency. So it gives you 10 gigabit throughput at a very low latency compared to something like fiber optic or Ethernet. And these DAC cables are good for servers that are located relatively close to where your actual application is going to be. And since I took the box, I plugged one card into the NAS and plugged one in my desktop, and then I did a point-to-point between the two. And then I'd use the 10 gigabit Ethernet to plug it into the network so that I could access the files, but not in a high-speed capacity. And then I went with a 3 meter cable, which I think is $20. So $21 for a 3 meter cable, which is basically the distance between my desktop and my NAS box. But you can go up to some of these longer cables, like 12 meters, which would be around 40 feet, I guess. And that would allow you to run into another room, not across a building, but it'd give you a fairly decent length that you would be able to run for having the box located a fairly long distance away from where you're actually working at. So again, DAC cables are nice. I like these things. Now, if you don't want to use DAC and you want to use some really long runs, you can go with something like fiber. Fiber is not incredibly expensive, but you can get some really long runs with it. The trade-off with fiber is that the fiber tends to be kind of brittle, but it gives you longer runs and it has a higher latency than DAC cables do. But you can get a 50 meter run, which is 150 feet, which means you could run this to the other end of a building. I mean, that's longer than the length of a football field. And so you could run this a long distance. In fact, you can run fiber for miles, in fact. So you can use this for really long runs if you need to do like a home run back to a server closet where this is going to be, and it's going to be a long ways off from where you're actually physically located. And of course, you can use Ethernet. Now, Ethernet typically doesn't terminate the cables with Ethernet, where you have it pre-terminated like these cables where the transceiver is built in. In this case, you have to buy the transceiver separately and then just plug an Ethernet cable into it. And so you'd use like something like Cat 8 Ethernet to get 10 base T out of this. So this is a very expensive option, but it does work. I would typically not use this because 10 gigabit Ethernet is a fairly new standard, and the hardware is still pretty expensive at this point. You can use Cat 6A too as well to get that speed, but it's pretty expensive right now. So if you're looking for a lower cost option that's been around and supported widely for a while, go with fiber or go with DAC because it's going to give you the same throughput, but at a much lower cost than using Ethernet. Especially if you're doing like a new run or something like that. So options for running SFP cards there. Now, I put all that together. My build is pretty straightforward. Now, for my build, I didn't have to do a lot of finagling. I had the drive that came in the machine that I used for the OS drive. And then I put a drive here, and I put a drive here, and then I put a drive here. And then I put the solid state right here. I mounted the solid state to the back plane of this. Then I plugged in the SATA cables into the drives right here, and then powered them off of the power supply here. It's got 4 terminals for 4 drives, and I disconnected the optical drive up there on the top, so I didn't use these 5¼ inch bays up here. But I could actually put a lot more drives in this because they make splitters for the ends down here, so you could put some splitters on this thing, and you would have to get for my motherboard, it only had 4 SATA ports on it, but you could get expansion cards for that and go with that. And I put my 8X PC, my 8X 10 gigabit card into the slot and then mounted it all up and closed it up and then installed the operating system. Let's go talk about the software now. Now we kind of have seen what I put in here in terms of hardware. So for software, I would recommend using TrueNAS. Now, TrueNAS is one of many options out there. It's not the only one, but it's the one I think that most people are kind of gravitating to nowadays for kind of these home-built network attached storage devices. It's used in enterprises as well among enthusiasts. So definitely check it out. I'm not going to get into the other ones, but it's the one I would recommend. There's kind of two flavors of TrueNAS. There's TrueNAS Core and there's TrueNAS Scale. Now, TrueNAS Core is primarily focused on just providing some of the basics of what a network attached storage device would do. And it gives you the ability to have a UI to manage your storage, and also gives you the ability to manage your networking, and with some additional options for maybe doing some things like managing file services or what have you for applications. But it's mostly focused on those core functionality pieces that a NAS will provide, which is a way to store the data and a way to connect it to a network. TrueNAS Scale is that plus some other things. So TrueNAS Scale does all the things that TrueNAS Core does, but it does it with the additional features of adding apps and containers and VMs to the mix as well. TrueNAS Core is based on BSD, which is the underpinnings for something like Mac OS, and TrueNAS Scale is based on Linux. And because of that, it has the world of Linux at its fingertips for the kinds of things that it can do. So you can use apps, Linux containers, and VMs, and so on with this one. So I ended up going with TrueNAS Scale, not because I intend on running anything beyond just a bunch of file shares on this, but I have the option if I want to. So installing TrueNAS is pretty straightforward. You basically download the media. It comes as an ISO. You then use something like Rufus or Etcher to make a USB drive. You plug that into your machine, you boot off of it, and then you install the operating system just like you would if you were installing Windows. It's really not hard to do. So once you get it installed, you plug in an Ethernet cable to it, and it picks up an IP address, and then you log into it. You set a password through the installation process, and you end up with the dashboard looks something like this. So once you're in, configuring this is pretty straightforward. The first thing you do is set up some data sets. You can look at your storage dashboard right here. You want to set up a data set, but the first thing you do is actually set up a pool before you set up a data set. So a pool is basically just a group of drives, and you give it a name, my pool or whatever you want to call it. You can call it dead pool if it's a bunch of dead disks. No pun intended there. Then you pick the data, you pick the layout. You can use a mirror or stripe. RAID Z1 is basically 3 drives in a stripe configuration with a parity bit. So stripe, if you're not sure, just pick stripe or mirror like I was talking about. Stripe it's going to automatically configure it. Mirror is going to automatically configure that. And you don't have to specify it. So I went with stripe, and then you have the disks. I don't have any more disks available because they're already dedicated to pools, but you would add that, and then you would have your drives, and it would format the disk and set them up accordingly. So you really don't have to do much when you create the pool. And once you have that done, you'll have a data set here. And then you come over here and you can then set up a share, and the share gets added to the data pool that you create here. So I went over here and set up an SMB share. So I went over and added the share. You give it a path. That's where it's going to mount it to. And then I put it right here under HDD pool, under Blaze is the name of the share. And that's what I'm using it for. Saved it. And then I end up with a share right here at this mount point right here. It's called Blaze share. And so once I have that up and running, that's where I'm going to connect to. Now the credentials for this are managed under credentials. And so you can set up users. I have a user for mine. There's the TrueNAS built-in user that's used for the admin. This is my user for logging into this particular share that I then assign to this share right here. Now everything else beyond this is kind of that extra value add that TrueNAS brings to the table. So you can bring virtual machines if you want to. You can build your own virtual machines and bring them here. So you can add a virtual machine and have the data stored on the NAS as well. So you pick a guest OS, and then set up a virtual machine, and you can have that running right on top of your NAS. I don't know that I'll ever use this for virtual machines because that's really not why I built it. I have other machines that I use for that. And so I would probably use Proxmox or something similar to that for virtualization. But if you just want a basic virtualization platform, this is probably not a bad idea. The real benefit of this one, though, I think, is the apps. And this is really where I think this shines. It's because it gives you the ability to add apps to your network attached storage that are going to be oriented towards storage. So if I come over here to storage, I can look at these and see and just scroll them to kind of see what is available, and they're sorted. So if I wanted to have some kind of AI app, Olama installs some LLMs. If I need a GPU for that, but that would be one. Database apps, financial apps, games. If I want to host Minecraft servers, I guess. Home automation. You could use home automation. This one also has, I think, Home Assistant, which is home automation as well. It didn't show up here in this grouping. But these are for managing containers, different media-oriented apps. You have a lot of different things here that you can install. Productivity, different apps there, security applications, storage for different kinds of storage options. There's just a ton of things here. rsync daemon is a nice one for burning backups. I've used that. You have different database. Postgres is a database. File stash is for different kinds of FTP and different kinds of protocols like that. SFTP is for lightweight type storage, and just a lot of different options there. If you wanted to install Nextcloud, which is, I need to go back to Discover here and type in Nextcloud right here. Nextcloud, if you want to install this, is a great option for having something to run just a file sharing service that you can install an app on your phone or on your desktop and sync data back and forth using a web UI and then an app experience. So something that I've used in the past. I don't use this anymore, but maybe in the future I will. But I was using something in the cloud now. I use OneDrive instead of Nextcloud because I have storage there because I wanted it offsite rather than something that I would lose if my house burned down. But in any case, I have that option if I want to use it. So lots of apps there. So once you have all that set up and you have your storage, it's pretty straightforward to connect to. Now, you can use the IP address. So if you want to hard code their IP address in to the configuration, that's certainly doable. If you have a DNS server and you want to add an alias to it, you can do that as well. It doesn't really matter. TrueNAS doesn't care. But once you have it set up, you can then have your drives all configured right here, which I'll show you what this one looks like here. And let me see here. This right here is my drive right here that I have shared. And so I have my storage right here that I have set up, and this is my wife's storage. And so this is just mounted at that file share that I created. So that's the IP address of my high-speed NIC card that I put into the NAS, as well as I put another one in my desktop. So I'm accessing this over high-speed DAC cable at 10 gigabits, but I also can access this over the Ethernet as well at 1 gigabit per second. So for my applications, I'm using this one. And so I can copy files to and from this. And that's actually what I'm writing this video as I'm recording it. It's actually writing it to this drive right here. So as I record it, everything is written there, and now it's available on my network as soon as I'm done recording. So that's the tour of TrueNAS. Very easy to use. And it's the one that will probably be the one that you would probably want to use as well. So that's my build out the door. I think my total costs in that build are probably less than $275. And like I said, most of that's the storage that I put in it. As far as the networking goes and the machine itself, that was fairly inexpensive. But at the end of the day, it's going to serve me for what I want to use it for, which is just to have the capacity to do photo and video editing. That I'm really not going to be using it for like personal photos and things like that. But anyways, it'll be there. And if I need to use it for other things, I have the option for expanding and going that route if I want to. So I hope you like this video. If you like the video, share it with your friends, like and subscribe. And I hope to see you on future videos.
If you like this content, please consider subscribing to the channel by clicking on the subscribe button. You can also like this content by clicking on the thumbs up or share this content with your friends, and also comment in the comment section down below. You can also find me online at www.blaze.net or on Twitter at @TheOneMule. And as always, thanks for watching.